Assalamualaikum and good afternoon. Well, I'm taking this in the afternoon. Okay, so for this video, we are basically going to solve this part of 4.6, where we're going to do the position analysis of crank slider of 4.6. So this is the initial position, where we have this link at 45 millimeter, this is at 100 millimeter, and the initial angle is 30 degrees. So now the question now, this is the configuration. Then reposition the link as the 45 millimeter crank is rotated 120 degrees clockwise. That means this crank here will be rotated about 120 degrees. 120 degrees. Then we need to determine if this is being rotated here, it will be basically go forward and going backward again. So it will be somewhere. We have to check the displacement. Okay, let's start by drawing the kinematic diagram. So we're going to, okay, in this case, use this blue. I like to always draw the straight line. Okay. So in this case, you know the total is basically total length of the crank plus connecting list 45 millimeter plus 100 millimeter, which is 145 millimeter. You can basically create up to, in this case, 14.5 cm or 14.5 cm. Okay. You can, this is 1:1 scale, so you don't need to rescale it. So let's say we choose one here, another one here. Okay, so this will be the joint for the crank, and this will be the maximum displacement of the piston, or the joint of the piston. So now let's draw the first position. It's 30 mm. I can choose different color here. 30 mm. Sorry, 30 degrees, and it's 4.5 cm. Okay, we just align this. So let's get 1, 2, 3, 4, 5, 4.5. So this will be the end. Now we need to draw this link. Okay, so the length is basically 10 cm. So what we can do is that, so we're going to create this part. Try to maintain the same color. It should be 10 cm. So we measure. It's a bit crude the way I'm doing it, but it's okay. It's about 10 cm here, 100 mm. So here, so this will be the position. Okay, so just using the same color pencil is easier. So this is the original location, original configuration. So now let's say this is for the original. Let's say we use red for the new position. Okay, 120 degrees, so we have to measure from here. Okay, 120 degrees, 120 degrees, somewhere here. So it's 4.5. Okay, basically it will be 1, 2, 3, 4, 4.5. It's almost 90 degrees. Oops. Almost 90 degrees. Then we have to measure 10 cm. So from this point, this is the location. Sorry, this is the new position. So we draw again. Okay, now this is the new position when it's 120 degrees. Okay, so this is 30 degrees and this is 120 degrees. That is actually almost 90 degrees. Then we just need to measure what is the distance here. So it is almost 5 cm, but it's not. It's actually 1, 2, 3, 4, 0.5, 6, 7, 8, 9. So the distance is actually 4.9 cm, or or 49 millimeter. So this is basically the distance that we want to find from the original. Okay, I think that's all.